Okay, we're going to do the review for the inequality test. We're going to do every problem. So follow along and write everything down in your paper. We have number one, what number divided by 3 will give you -2? So you might be able to figure that out without showing the work, but you still have to show that work. That's part of your credit on the test. So in order to cancel something out with a fraction, if it's on the bottom, you just need to multiply on top. So those will cancel out, equal 1. And we'll have -2 times 3 is -6. Okay, and just a little review on this for the signs. We have open and closed circles. Okay, and the open ones will be the greater than and less than, and the closed will be the greater than or equal to and the less than or equal to. So on a graph, you'll see an open circle for these two symbols and a closed circle for those two symbols. Okay, so basically, if you have a line underneath, then you know it's going to be filled in. Okay, so on the graph, let's go down. I'm just going to put -6 anywhere. You don't have to fill out any other numbers and put 0, 1, 2, 3, 4 or anything. Just put the one answer. And this is open circle, and we want all the numbers bigger than -6, which are going to be to the right. Okay, because this would be -5. Up here would be, bigger numbers. So that's why it goes to the right. Okay, let's go to number 2 here. We got two-step equation, so always do the addition subtraction first. So we're going to subtract 5 on both sides. Okay. We got -2 times what? Greater than or equal to 15. And divide both sides by -2. Okay. Now when you divide by a negative, you need to switch the sign. Okay. And you can just leave your answer as -15/2. Of course, that's the same as, let's see, 2 goes into 15 7 times, with 1 left over, so that's the same as -7.5. So on the number line, you can put either one of these. It's fine just to put -15/2 and your open circle and going to the left. That's okay. Okay, let's go to number 3. We got variables on both sides. So I'm going to start on the right-hand side with the variable. Do the opposite, so I'm going to subtract 2x on both sides. I'm also going to take care of the number on this side. So it's +2, so I'm going to subtract 2 on both sides. Okay, so the goal here was to get rid of the numbers here on the left and the variables here on the right. So I'm just left with variables here and the numbers here. Okay, so 8 minus 2 will get 6 times what is less than or equal to -5. Okay. And let's divide both sides by 6. So we have x is less than or equal to -5/6. And again, just put that on the number line, -5/6. This time it's since we have the line underneath, it's closed. And we're going less than, so it's to the left. Okay, let's go to number 4. Yeah, number 4. We got some distributive property to do. So we can do 3 times 4 and get 12. And do 3 times 2x, get 6x. That's less than or equal to -18. And like before, start on the side of the variable. We got a +12, so I'm going to subtract 12 on both sides. Alright, so we get 6x less than or equal to -30. And then let's divide both sides by 6. So x is less than or equal to -5. Now, you don't flip the sign here because I didn't divide by a negative. I divided by +6. So you notice the sign is the same, and that's good. So we got -5, and we got a closed circle, and going to the left, less than. So we have a compound inequality, which basically means let's graph both of these on the same number line. And there's nothing to solve here because the variables are already by themselves. There's no work to do here. We just go straight to graph. So we have -4 and +2. Both of these are open circles, no line underneath. So open and to the left, less than, and open to the right. That's greater than. And that's all there is on that. With the and, it's kind of like the opposite of the or. The two numbers, or the two graphs, will end up combining together, because we'll have this going this direction, right, because it's greater than, but then this is less than, so it goes the other direction, right? So really the graphs just end up connecting. So we get everything between -1 and 4, and the proper way to write that answer, you have the two endpoints, right? And you put the x in the middle of them. So both the graph and this inequality mean the same thing. All the numbers between -1 and 4 are the answer. So on the graph you can see that all these numbers here to here are the answers between -1 and 4. And the way you write this means the same thing. The answers, which is the variable x, are all between -1 and 4. And you only have this special way of writing the answer when you have an and. So you notice we didn't do that for or. We just left it alone. There's no special way of writing the answer. Okay, let's keep going. Solving more. So these are just like the ones before. We're just going to graph them on the same number line. So I'm going to add 3 to both sides on this one and divide both sides by 3 on this one. Alright, so I'm just doing the inverse operation. So if this is subtraction, I'm going to add. This is multiplication, so I divide it. So those cancel, those cancel. So x is less than -3, or it is greater than +3. And the or gives you an idea that the graphs should be going away from one another. When you see or, think of away. So we have, let's see here, -3, +3, okay. And this one has an equal to, so that one's closed. But this one does not, so this one's open. And final graph. So number 8. Alright, here's that notation we saw in number 6. So just start in the same place we always do, with the variable. And this is 4 times a variable, so we still undo it the same way. Divide by 4 everywhere. So even though it's 3 places, it's okay. So we have -4 less than or equal to x less than 2, which means all the numbers between -4 and 2. So we got -4, we have 2, and again we have an equal to here, so that's closed. And this one's open. Okay, there we go. We have a two-step problem here. There we go. Alright, so we got a two-step here. We're going to first do the adding and subtracting. So subtract 3 on both sides. So we have what number divided by 4 is bigger or equal to -1. So can you think of the number, if you divide it by 4, you get -1. Okay. And let's go ahead and solve for it. So this is division divided by 4, right? So we're going to multiply by 4 to undo it. So multiply both sides by 4. We get x is greater than or equal to -4, and that makes sense, because -4 divided by 4 is -1. And similar on the other side, divide both sides by 9, because this is multiplication. And 36 divided by 9 is positive 4. You know this is an and, so these are probably going to be connected, going towards each other. So we got negative 4 and positive 4. So that one's closed, going this direction, and this one's open, because there's no equal to on positive 4. Alright, let's go over to the next page. Oh no, go to the next problem. Okay, don't have to graph these, so we're just going to solve them. Alright, so we're multiplying by a fraction here. Okay, it'd be helpful. I know you guys can't do this, but I'm just going to get that out of the way. There we go. Multiplying by a fraction, the way to undo that, you can't divide like normal, right? Usually if there's a number in front we're multiplying, we divide both sides. But instead, since it's a fraction, we're going to cancel both of these out at the same time. So to cancel out a 3 on the bottom, we want a 3 on the top. To cancel out a 2 on the top, put a 2 on the bottom. So that's called the reciprocal. Do the same thing here. Okay, the negative 5 is automatically on the top, so we want 3 on top and then 2 on the bottom here. Okay, so 2 over 2 cancels out, equals 1. 3 over 3 cancels out, equals 1. So you have just 1x. And nothing cross cancels here, so we'll just get negative 15 over 2. That's the same answer we got up there earlier, which is negative 7.5. And no graph necessary, so we're done here. A few more solving. Again, when you have variables on both sides, start on the variable on the right-hand side. Because that's normally where the variable is not supposed to be. That's why we start over there, to get rid of it. Okay, still get rid of the number on the left. So we have negative 3x and positive 3. There we go. So negative 3 times what is positive 3? So divide both sides by the negative 3 equals 1. Divided by negative, flip the sign. And 3 divided by negative 3 is negative 1. Number 12. We have variables on the same side, so you don't want to add 5x or subtract x. You actually just combine these together. 1 minus 5 is negative 4, because they're on the same side. So that's different than this. When they're on different sides, you go ahead and subtract. If it's positive 5x, we subtracted, did the opposite. But when they're on the same side, you just combine them together, 1 minus 5. Okay, less than negative 16. And once again, we're dividing by a negative, so you will flip the sign. So we'll have x is greater than positive 4. Okay, let's flip it over to the back, please. Yes. Okay. So we got some variables on both sides with parentheses. So just like combining everything we did on the first page. We had a problem that had to distribute, and we had a problem with variables on both sides. So we're just combining those together into one problem. And just watch out for your negatives. So negative 2 times 3 is negative 6. And negative 2 times negative 1, positive 2. And again, we have a variable on the right-hand side, so start there. Do the opposite. Add 6x to both sides. Go to pink and subtract 10 on both sides. So we got 10's canceling out. 6 minus 6 cancels out. We have 5 plus 6 is 11. And negative 10 plus 2 is negative 9. And go ahead and divide both sides by 11. And don't worry that 11 doesn't go into 9. It just means your answer is a fraction. And we just leave it as negative 9 over 11. Don't change anything. And let's go to the right. Continue on. We've got a fraction here, but they're the same denominator. They're both 5, so that means it's easier. So remember, don't say it's hard because it's a fraction. Look what we have to do as far as the work. We have to do 1 plus 4, which is 5. And that's as difficult as it gets. And it's over 5. And of course, 5 divided by 5 is 1. So, definitely doable. So we got another two-step equation. So this is a positive 9. I'm going to start there by subtracting 9. Okay. So we have negative 2 times what gives us 0. Okay. Now before you go on, ask yourself, well, negative 2 times what is 0? And you'll probably come up with 0. So you know the answer is 0. So sometimes that's good because people look at the 0 and not be sure how to handle this 0. But if you already know the answer is 0, you can say, oh yeah, 0 divided by negative 2 is just 0. And that's okay. But we did divide it by that negative, right? So don't forget that part. Switch the sign. So it's okay to have an answer of 0. Let's go down to 16, almost there. Getting closer. Okay, so variables on both sides. And what we're going to see is a little special case on this one. We'll have negative 9x plus 6. Again, it's negative times a negative 2. That's positive 6. Okay, I'm just going to copy down the other side. Nothing to do there. Start with the variable on the right. We have a variable on the right. Let's start there. Do the opposite. Let's add 9 to both sides, 9x. And subtract 6 on both sides. Okay, and something peculiar happens here. Right? Everything on the left cancels out, which means it's just 0. They're both equal to 0, but you only have to put 1 0 there. Right? But the variable over here cancels out as well. And we get 12 minus 6, which is just 6. So it's peculiar because the variables are gone. So there's no one unique answer. We got something that's a special situation. So ask yourself, is 0 actually less than, smaller than 6? Right? And the answer is no, it's false. It's true. 0 is smaller than 6. Right? That is a true statement, which means there are infinite solutions. Infinite solutions. Okay. Now, if it was false, we would have had no solution. So that's the other side of this. But this is definitely a true statement. 0 is smaller than 6. So we have infinite solutions. So this would be the answer, infinite solutions. Write that out. Okay. If you had to actually graph that, let's say you had a number line, the graph would actually be everything on the number line because it's all the numbers. That's what a graph would look like for infinite solutions. Let's go to 17. Okay, we got a variable here, so I'm going to start with this and subtract it out first. We got negative 1/4 x is greater than negative 2. 2 minus 4 is negative 2. Okay, and we're multiplying by a fraction, so instead of dividing, I'm going to do the reciprocal. 4 on the bottom, put 4 on the top. Okay, 1 on the top, put a 1 on the bottom. There's a negative here, I'll put a negative here as well. Do the same thing on both sides. Negative 4 over 1. Divided by a negative, both sides. Flip that sign. So everything cancels. Alright, negatives cancel, the 4's cancels. The 1's technically cancel too, but the 1's will just equal 1 when they cancel. So we have 1x, and we have negative 2 times negative 4, which is positive 8, over 1, but we don't need to write 8 over 1 because 8 divided by 1 is just 8. So x is less than 8 is fine. Let's give this one a try. Do some distributive property. Once again on both sides. We have 4x plus 12. And we have 4x plus 20. Okay, variable on the right, let's go ahead and subtract that out. Do the opposite. And number on the left, let's subtract that. Since it's positive 12, subtract that out. So, same situation we had on number 16. The whole side cancels out, equals 0. And the variable on this side cancels out as well. So this is one of those special cases, 20 minus 12, which is 8. Okay, ask yourself, is this true or false? Is 0 bigger, greater than, is 0 bigger than 8? And no, that's a false statement, right? 0 is not bigger than 8, so there is no solution. Okay. And sometimes for the graph, you can't really graph no solution because there's no answer to graph, but you might see this symbol that looks like that instead. So that means no solution as well. Okay, just a few more. Let's look at writing an inequality for this. So we can tell because they go away from one another, we're going to use or. Okay, so the fact that they go away from one another means it's an or compound inequality. So we have one that's going to the left, starting at negative 10, another one that looks like it's starting at negative 9 right there. All right. Now look at the symbols closely. Okay, this is an open circle. So going to the left, so open going to the left is just less than. But this is a closed circle, so that's closed. So there's a line underneath, right? So when it's a closed circle, you have the line underneath. So that would be the compound inequality for that graph. And again, you have to have that word or because they're going away. Okay. Here is kind of the opposite. They're going towards each other, right? So you can write it as an and statement, but the easier way to do that, okay, negative 9 right here, would just be to use these numbers as they are and just say, well, it's everything between negative 9 and negative 6. And once again, just be careful because these are closed, so these do need to have a line underneath, both of them. Okay. So for these kind of graphs, it's pretty simple. It's just whatever number is on the left side of the graph here is on the left side of your answer here. Any number on the right side is on the right side here, and put the variable in the middle and make sure you have the right closed or open signs. They always point to the left, no matter what. That's why I was able to put those in right away. Okay. All right, so that's the bulk of all the inequality stuff. Now we just have a few review things down here with proportions. Okay. So we want to make sure we don't forget the old stuff. So remember, if you have a fraction equal to a fraction, you can always just cross multiply all of these. Okay, so we have 2 times 10, which equals 9 times 3x. And we did a Khan Academy on this. Okay, variables right here. So 27 times x, let's divide by 27. That cancels out. And check to see if 20 over 27 reduces. And nothing goes into both of them evenly. So that's just your final answer. 20 over 27 equals x. Another proportion. This time we have the adding, subtracting on one of them. So just put parentheses around that when you see that. So we'll have multiply these two together, right? So we got negative 15, and then multiply these together, and we'll have 6 times x minus 2 with the parentheses. So we have to distribute to solve. 6x minus 12. And go ahead and add 12 to both sides. And then divide both sides by 6. Negative 3 is equal to 6. So 6 times what is 3? You might be able to figure that out. That's a half. Half of 6 is 3. So we get 3 over 6, which is equal to negative 1/2. All right. Let's look at, let's see here. Translate and solve for 23. Let's see, we have the sum of 3. Let's zoom out a little bit here. That might help. There we go. Sum of 3 in a number. So sum means to add, right? That means to add. So we're going to add 3 in a number, and it's called our number n. N for number. So sum of 3 it tells us, sorry. It tells us the variable. We use y. I see. Sum of 3 times a number and y. Okay. 3 times a number and y. And 6 is negative 9. Alright, so the sum of 3 times a number and 6. So these were the two parts right here that we added together. And is always means equals, right? So we know we put equals negative 9. And it also says to solve, so we got to actually solve this. Subtract 6 on both sides. 3 times y equals negative 15. So 3 times what is negative 15? Divide both sides, and you get negative 5. Okay. Looks like we got one more down here to solve. 10 less than twice a number, m. So twice a number, m. And 10 less than that would be minus 10. Is equals 24. We can add 10 to both sides. 2 times m equals 34. There you go. 34 divided by 2 is 17. Okay, that concludes your review. Hopefully it makes sense. If you need to, you can replay anything. And of course, the notes and videos are on School Loop if you need to watch them again. I encourage you to do a second one, but see if you can do them by yourself if you just watched this whole video and wrote it down. Because you need to be able to do these on your own when you take the test. Okay, good luck.